I am Rajkumar Somorjit. I am a lecturer in mathematics and I will be teaching class 11 and 12 mathematics. Hi, today's topic is application of derivatives. First of all, akoina mamangi sigi chapter sigi mamangda akoina continuity and differentiability da akoina tamgre. What are the different forms of differentiation? Ada differentiation da akoina function makan gi differentiation kamain togudage haibdu mamangi chapter da akoina hairaga leikrabani aduna madugi differentiation dugi application sidaida akoina application of derivatives haib chapter sida akoi side makhatana akoi nainasi sidaida akoina application of derivatives si magi derivatives ki application harga akoina day to day life te su mayam lai aduga physical science su mayam lai medical science abu sijnei atopa social science abu sijnei ado space da and science and technology magi mapan nai de haitare magi application singse ana day to day life te su adum akoina norm da sijnei mayam se su adum application of derivatives se adum akoina loi apply to bi yai se akoina sigi syllabus ki matungina sidaida akoina thengna ka dausi ahamada rate of change of quantities. So the rate of change of quantities, the quantity amagi mabani gi rate si akoina ama khangadi atopa khangdaba amagi akoina rate of change identify to thopa masi derivatives ki mateng loroga yam line akoina rate of change of quantity hot pi. Next to find the increasing and decreasing parts of a particular function. Function amagi increasing jaga krai wai doi adoga decreasing part na kada wai doi haibsi akoina application of derivatives ki mating loroga akoina sijinaraga akoina identify to bi matangda to find the equations of tangent and normal curve amada akoina apiba point amada tangent natraga normal makoi gi equation putokpasi akoina derivatives ki mating loroga akoina yam chamcham na putok pi matangda akoina approximation haiba amasu thengnarakani approximations dana akoina some say root 2 root 3 gumasi akoina mai value singsi akoina puthok matamda akoi derivatives ki through degi akoina approximation haiba topic sida akoina nainabi yai. Then to find the turning points on the graph of a function amagi mai turning point akoina turning point si khang tarde identify to ngam tarde akoina function si mai maximum extreme values sara khangnei maximum values natraga minimum values sing identify to buda akoina derivatives si mating lorga sigi application of derivatives sida season rakani. Now ahan topic rate of change of quantities sida akoina rate of change of quantities si nainabada ahan akoina hana day to day hana already lower class tagi koina thengnaraba ds by dt haise masi kari represent toge haisi kaiguma s na displacement orba t na time oitardi ds by dt se koina ds by dt represents the rate of change of displacement s with respect to time t ara khangni. Similarly dy by dx natraga f dash x haisi makoi se koina the rate of change of y with respect to x hierarchy. Again, dy by dx differentiation dy by dx at a particular x equal to x naught natraga f dash of x naught hierarchy akoina represents the rate of change of y with respect to x at x equal to x naught hierarchy. Anas dida akoina ds by dt degi akoina velocity hierarchy khangnaba rate of change of displacement with respect to time masigi interpretations degi akoina dy by dx akoina the rate of change of y with respect to x dy by dx at a particular instant x equal to x naught represents the rate of change of y with respect to x at x equal to x naught masigi mayam sijinarga akoina rate of change of quantities kamaina puthokadagi yengse sida dy by dx dy by dx is sometimes mass positive obi natraga mass negative obi karam kanda positive oigani natraga karam kanda negative oigani haibasi karigumba x ne increase tropin matungina y su mass increase to raba adu itargadi akoina dy by dx haibdi the rate of change of y with respect to x mass positive quantity oigani. On the other hand x ne increase to matamda y gi value se mass decrease to raba adu itargadi akoina dy by dx akoi negative quantity oigani. Let's see, if two variables x and y are varying with respect to another variable t, that is if x is a function of t and y is a function of another function of t, then by chain rule akoin dy by dx in parametric form da kamai puthokane akoin mamang gi chapter da tamme sigi formulas da dy by dx si the ratio of dy by dt to dx by dt ne provided dx by dt akoi denominator quantity sima 0 tabi ade masigi formulas de gi akoina dy by dx value se akoi the rate of change of y with respect to x can be calculated using the rate of change of y and that of x but with respect to t. So mind to now akoina the rate of change of y with respect to x si akoina calculate to hai matam da akoina y gi rate of change natraga x rate of change khangaba sigi formulas da akoina fit tawsilaga akoina calculate to bi sida example ama yengsi example sida a stone is dropped into a quiet lake and moves in circle at a speed of 4 centimeter per second. At an instant when the radius of the circular wave is 10 centimeter, how fast is the enclosed area increasing here? Akoina ising leng da ising amada akon nung ama thada matamda akoigi isingi ipom si circular oina masi sandore sandrok pai chang si masi 4 centimeter per second da sandrok taragadi ana mana sandrok matamda mai area sum chauthorokani chauthorokadabi area do adu madugi rate si kya oigidage when the circular wave si akoina mai gi radius na 10 centimeter oi matamda madugi instant da akoina laigadaba increase area du putho the rate of change of increase in the area haitare ko madu putho usineba kya akoina problem oina masi solve tawda sumaina solve tawgani let a be the area of the circle whose radius is r then area gi formula da a equal to pi r square fange then akoina sida puthok to isi dA by dt putho aibni dr by dt gi value si akoina question da value p den lere adu itare de akoina the rate of change of area with respect to time t si akoina nakan animal difference to thoga dA by dt gi value se 2 pi r dr by dt and given that dr by dt is 4 centimeter per second p, therefore dA by dt when r equal to 10 centimeter height targadi akoina radius ki value 10 hapsal dA by dt equal to twice pi into 10 into 4 equal to 80 pi fangi. Thus when r equal to 10 centimeter the enclosed area is increasing at the rate of 80 pi centimeter square per second. So maina koi solve tawgani cham na example amaga mu yengsi a man of height 2 meter walks at a uniform speed of 5 km per hour away from a lamppost which is 6 meter high nega. Find the rate at which the length of his shadow increases ne sida hai si lamppost ama lere masigi lamppost degi akoina nupa amana sum laptho go sum chatle laptho chat matam sta suppose at a particular time t akoi nupa si position c a v si da leiden khalase ade after some instance mai sum lapthrok tini lapthrok matam da ma si a dias b dias yokre a dias b dias rok matam da ma sagi ahamba position a b da leingai da mai length of the shadow c b na represent to web adogi mu a dias b dias da mu lak matam da mai length of the shadow si c dias b dias have increase to rokane ko adu masigi sida problems da hangisi find the rate at which the length of his shadow increases akone solve to matam da solve ko mind to godagi yengminasi let sigi figure sida OPC ngasai gi 6 meter wangba lamp post lower si P na ko gi lamp du gi my position we hello at a particular time t let AB equal to 2 meter be the meant let OBC akoi S sangin lower si in meter aduga BC na R sangin lower si then BC is the shadow of the man ne ds by dt ngasai gi speed of the man si 5 km per hour p akoina hoji putok to se magi length of the shadow have the r si magi rate of change si kya oidage that is dr by dt putho haibani ko now sida akoina figure sida triangle avc siga triangle poc siga similar oi similar oi se akoina class 10 da naina kre triangle si ani similar oi se akoi irai laina akoina ubu fangi adu itadi properties of similar triangles dagi akoina corresponding sides of similar triangles are proportional adu madugi properties sinarga BC is to OC siga AB is to PO ga managani sidagi akoina R divided by R plus S equal to 2 by 6 aidi magi corresponding value singi sinjan biraga akoina masi equation ni solve to matamda S equal to 2R fangi adu itardi nakan animal differentiate to thom matamda ds by dt si 2 times dr by dt fange sidagi dr by dt gi value se akoina 2.5 km per hour fange ko ana sumain tawdna the length of the shadow increases at the rate 2.5 km per hour na akoina irai line solve to bi hai next mathangi application of derivatives ki another useful application is how to find increasing and decreasing parts of a function sida akoina increasing natraga decreasing function haibsi karino hana identify tobam changi identify todringa da akoina karam function bo koina increasing function koi natra decreasing function koi haibse akoina hana nainaraga yengisi consider the function fx equal to x square x belongs to the set of real number sida my actual graph si sida ma parabola ni parabola opening outward and whose vertex is at the origin masigi parabola sida yengsi akoina graph of the function sida as we move from left to right along the graph to the left of the origin ki left thangda akoina along the curve sida akoina chatlagi yeng matamda akoi x value sing si left and right rom na chat taraga di x sum increase tawtoni for example -2 dagi -1 then -1 dagi 0 on la si ko adu tadi x value si increase tawdune ba adu tadi increase taw matamda y gi value di ngasai gi akoina curve si yeng si -2 gi mapada ma se 4 leba -2 gi square is 4 ni adu -1 gi square is 1 ni aduna -1 gi mapada akoi gi function ji value si 1 le ada 0 gi mapada 0 le ada in short as we move from left to right along the graph to the left of the origin the height of the graph continuously decreases ne graph si akoina decrease to win low ne masida sigumba decrease to x ni increase to matamda ngasai gi function ji gi value se mai sum mayeng sum ta tharaba adu tadi masigumba function ji bu akoina decreasing function ha kangne for this reason the function is said to be decreasing for the real number x less than 0 chi 0 gi left thang side ni ko on the other hand adu 0 gi right lom da amuk yengsi as we move from left to right along the curve to the right of the origin the height of the graph continuously increases x value se akoina right lom da sum chat matam da ma si increase to matam da di akoina graph si gi value se amuk se ma si tam na sum wangkhat pa hokre ana sigumba for this reason the function is said to be increasing for the real number x greater than 0 ana sigumba nature si bo akoina increasing kawe ana akoina functions da sig functions da akoina function am kan kan increasing way function am kan kan decreasing way haibse masi graph sig mating lorga akoina yam icham cham na u fangkhre according to this discussion we have the following definition here let I be an interval contained in the domain of a real valued function f then f is said to be increasing way ge hai targadi akoina si condition satisfied to godobni increasing on interval I if x1 less than x2 in the interval I implies f of x1 is less than or equal to f of x2 for all x1 x2 belongs to the given interval I and the function is said to be strictly increasing on I if x1 less than x2 in I implies f of x1 is strictly less than f of x2 for all x1 x2 belongs to I sida akoina strictly increasing haiba ma increasing kaktang haiba ma ani di thoi ko increasing high sina akoina equal to or su yaba habi function si value si mai sum wangkhat kre ada sometimes wangkhat pas lepa ma constant when chat pasu yaba ko ado handarak padi yadaba handarak pagi part yaudaba function ji bo akoina increasing function na hari ado ma se koi adum x na chakolak ma tuna function value sum adum chakolaba correspondingly ko ada directly proportional in sum chakolak taragadi akuna function je akuna strictly increasing function haganeba say the graph si yengminasi masi graph si strictly increasing function ni x1 gi x2 gi sing asai interval I is the belong to ba value ani khangni mas the x1 gi mapa da leba f of x1 gi value siga x2 gi mapa da leba f of x2 gi value siga f of x2 gi values na f of x1 dagi wang be hele habidi chaw be hele ko ada sigi mongs da labor functions bo akoina increasing ko we sida ulliba function si strictly increasing function makhal amani again decreasing function haragadi function si ngasai gi domains da akoina value ani lo si x1 x2 na sahulasi aduga f of x1 siga f of x2 siga masi f of x1 gi side sin saw be helaba manabasu yai ado itadi function ja koine decreasing oi haigani and strictly decreasing sina akona f of x1 is strictly greater than f of x2 orba adu itadi function je akona strictly decreasing function ne haigani adna masi graph sida ulisi strictly decreasing function makal amani sida x1 ge x2 si x2 na right lay masing sina akona real number system da akona number line da right lay masing sina adum always solve hengani aduga f of x1 ge f of x2 ge se f of x1 wang be hele f of x2 degi aduna masigumba type of function ju akona decreasing function koi mabani manaba jaga amata leite sigumba function je akona strictly decreasing function gi case makal amani against the function si kaigumba ma si everywhere ahongba naidraba. Let I be an interval contained in the domain of the real valued function f, then f is said to be constant on I if fx equal to c for all x belongs to I where c is some constant never ko. See the graphs the yeng c is some constant amane and x1 x2 sing sai interval du leiba akoi value makal ani lor si adora f of x1 f of x2 is the hong manai de mabani chap manana dum leiba ko ada mafam khudimok to sumaina hong manai da increase to do decrease to do c case wo kona constant function har khangne. Here first derivative test for increasing and decreasing function masigi theorem sida akoina derivatives ki mating lorga akoina function je kamai to no ma si increasing oi natraga karam jaga da karam kanda akoi decreasing oi gadagi have si derivative sinarga sigi theorem sina takani. Let f be a continuous on closed interval ab and differentiable on open interval ab, then f is increasing in the closed interval ab if f dash of x is greater than 0 for each x belongs to the open interval ab. F is decreasing on the closed interval ab if f dash of x is always less than 0 for each x belongs to the open interval ab. And f is a constant function in the closed interval ab if f dash of x equal to 0 for each x belongs to the open interval ab. Sige proof si akoi yengmina si proof si ahamada first part a si khaktang hana proof torogi yengsi. Let x1 x2 belongs to the closed interval ab such that x1 x2 say x2 na right lane low si ibd x2 na chawbi hele ko. Then by mean value theorem there exists a point c between x1 and x2 such that mean value theorem akoina mamangi derivatives ta akoina mean value theorem tamkhre ana karigumba function ama continuous or closed interval da adugo open interval du ne ma si differentiable oitar di adu ngasagi open interval du da akoina yamdra the point c have a point ama akoina soidna fangani madui mapada derivative 0 tagani have a madui condition da sida akoina apply tore sida f dia c gi value si sumaina satisfy to akoina mamangi chapter da masigi part si akoi haikrabani sidagi akoina solve toroga f of x2 minus f of x1 is equal to f dash c into x2 minus x1. C conditions da akoina part a da function c increasing oi gi haitar dimagi f dash x positive oi gadamni have a pot c mesti imply to targadi f of x2 minus f of x1 se ma si greater than 0 fangane since given the f dash c is ma positive oi benina sidagi akoina f of x2 is greater than f of x1 fange aduna sidida akoina kari condition fange x1 is less than x2 na akoina lowe hobda aduga hause akoina fangakpada f of x1 is less than f of x2 for every x1 x2 belongs to the closed interval ab na c condition ji fange masi karamba condition no hagadi akoina ngasai increasing function gi condition du bune adna function ji akoina sidida increasing ni haibiduma akoina f dash x kaigum positive oitardi function c madugi jaga du increasing oigani habse akoi sida proof torisna akoina irai laina ubu fange adunga part b ge part c ge si sida proof toris maina chapmana proof tobiai masi sing si students singna masi try tobiu sida example am yeng si so that the function f given by fx equal to x cubed minus 3x square plus 4x x belongs to r is increasing on r masi function is increasing function ni si akoina ngasai gi derivative test sinarga akoi solve todoni ko ahamda test sinarga direct solve todringa da ai hyphet maigi graphical representation si the so toge sida piriba graph si ngasai gi function fx equal to x cubed minus 3x square plus 4x have a function se masigi actual graph ni graph si da koina u fange function si always ma si x value increase tor matam da left gi right om da law the function is sum wankale and ma si always everywhere increasing oiba ko si kumba si ko ado koina example si da pdc si example si solve to si using application of derivatives की part अमो इन को solution दा अकोने fx सी हम दा differentiate तो थे differentiation की rules पाला कोई differentiate तो रे f दिया x सी 3x square minus 6x plus 4 से अकोने simplify तो थोगा f दिया x सी 3 times x minus 1 whole square plus 1 सिदी अकोने x real number ओय मतंदा x minus 1 की whole squares दी always positive oil learning and 3 na multiply to sulaga plus 1 amuk to mutamda masi always 0 dagi chawa masing ama adum x na any real number long mutamda adum sumdan legani mas positive oil legani adui ta di f dia x se kai dore mas 0 dagi adum chawdun lere adui ta nga sai gi first order derivative test gi matungina masi f dia x positive oil tar di function si increasing or ni have a conclusion pba again example among yengsi सिदना function नम पीरे function सी माई increasing ओइब जगह अदुगा decreasing ओइब जगह कदाई कदाई वे देलेगे have to identify तोबा सी problem नि find the intervals in which the function fx equal to x square minus 4x plus 6 is increasing or decreasing है graph सी हानि यंग मिनसी सिदा solve actually solve तो ड्रिंग एदा मस्ता graph of the function सी मासी parabola opening a word whose vertex is at 2 गी मपाद लेको 2, the masi vertex oi. And 2 gi left thangrom the function si masi decreasing oi, aduga 2 gi right thangrom the function si increasing function oi. And akwena si the actual graphical representations de akwena function si 2 gi left from the masi decreasing function ni 2 gi right from the increasing function ni hai sum ubo fangore ko. Masi si akwena application of derivatives ta akwena combine hot ki yeng si. Ahamada given function si akwena differentiate to thokani f dias x is twice x minus 4 fangi then f dias x na 0 taba jaga se akoi na 0 ga equate to thoga akoi kada wai the 0 ta ge have se hana identify to mutne x equal to 2 fangi sigi x equal to 2 is na ngasai gi real number line si akoi na 2 disjoint sub intervals divide to ko ana intervals kana kana no minus infinity de na 2 ba ma 2 degina plus infinity ba ma 2 gi mapada di f dias si 0 tarabni ko ana 2 gi left from the f dias ki value si kya no 2 gi right from the na f dias ki value se positive oibra negative oibra have do koina identify tok tok si masida analyze to masigi interval asida ye be interval si degi akoini irai laina khange 2 gi left from the level masing ama haita lorga sida f dias hapsal yengo sida masi negative quantity tholokani aduga 2 gi right from the level any masing ama lauraga sida f dias ki value sida akon generator yeng matamda positive quantity fange aduna 2 gi left thang side sida akona function je decreasing function ni haigani aduga 2 gi right thang interval sida function je akona increasing function ni haigani